Okay, just checking that this pops up. Very quick sound check. Sound check. Very quick sound check. Sound check. Send out the comms. Whoops. Get that back on. There we go. Right, everything's here now, so let's get cracking. Right, so we're back to it. We are back on Boot.dev today, and we've gone back a few steps and stuff. We ain't doing that again. We're starting from where we left off. Okay, so we're going to be finishing off this today. That is the end. We finish off all this, and then we're able to move on to the next module tomorrow. If we don't get stuck, but we'll see. We've got 2 hours on the timer. That was 2 hours started. We're going to get cracking on now. So okay, right, off we go. We're back to it. So we started a new chapter. We finished loops before. We're on lists today, and let's get going on the first one. So lists. A natural way to organize and store data is in a list. Some languages call them arrays, but in Python we just call them lists. Think of all the apps you use and how many of the items in the app are organized into lists. For example, an X, formerly Twitter, still Twitter in everybody's eyes. Feed is a list of posts. An online store is a list of products. The state of a chess game is a list of moves. This list is a list of things that are lists. Funny. Lists in Python are declared using square brackets with commas separating each of them. So inventory, iron breastplate, healing potion, leather scraps. Lists can contain items of any data type. In our example above, we have list of strings. Assignment. Let's work on Fantasy Quest's inventory. We can store items the player is carrying in a list. Fix our get inventory function by adding sword to the end of the list. Sword. Oh, whoops, short sword. That's my bad. We lost points off of the first one. Hooray! Oh, I like how you can see the little dots along the top. Actually, I didn't notice that last time. List continued. Sometimes when we're manually creating lists, it can be hard to read if all the items on the are on the same line of code. We can declare the list using multiple lines if we want, so typical of any programming language. Writing it in this way helps with readability and organization, especially if there are many items or if some of the items are too long. Keep in mind this is just a styling change. The code will run correctly either way. When would you declare a list on multiple lines? When there are only a few items, when there are many items and it's hard to read in one line. That one. Which types can be stored in a list? All of them. Boop. Which index refers to the second item in a list? Counting in programming. In the world of programming, counting is a bit strange. We don't start counting at 1, we start at 0 instead. Each item in the list has an index that refers to its spot in the list. Take the example as follows. So Bob is 0, Lane is 1, Alice is 2, and Brianna is 3, which refers to the second item in the list. That's 1. 0 index. Indexing into lists. Now that we know how to create new lists, we need to know how to access specific items in the list. We access items in a list directly by using their index. Indexes start at 0 the first item and increment by 1 with each successive item. The syntax is as follows. Best languages. Hard to kind of covers all the bases, hard to doubt that. Print 1, prints go because index 1 was provided. Assignment, we need to allow our players for access to access items in their inventories. Fix our get leather scraps function by changing the value of item index to the index in inventory that holds the value of leather scraps. So leather scraps is going to be a 1. Let's check it. Oop, easy peasy. List length. The length of a list can be calculated using the len function. The length of a list is equal to the number of items present. Don't be fooled by the fact that the length is not equal to the index of the last element. In fact, it will always be 1 greater. The length of the list is equal to the number of items. Don't be fooled by the fact that the length is not equal to the index of the last element. It will always be 1 greater. Assignment. Some of our players' inventories are huge, so looking through the entire list is cumbersome. Let's find an easy way for us to get the index of the last item in their inventory. Complete the getLastIndex function so it returns the length of the inventory list minus 1. So return len inventory and then minus 1. Passed it all. Pass it again. We can also change the item that exists in a given index. For example, we can change leather to leather armor in the inventory list in the following ways. So you can just put an assignment, and then it becomes that. Speaking of assignment, Fantasy Quest is trialing a new inventory system for their hardcore game mode. If a player has iron ore or an iron bar, it's always stored in the second inventory slot and they can only have one or the other. Let's finish the smelt ore function. When a player tries to smelt iron ore, we need to change it into an iron bar, but only if they already have iron ore in the inventory slot. So, iron ore or an iron bar is always stored in the second inventory slot, they can only have one or the other. So we do like if inventory, and it's the second one, so 1 is equal to what do they say, iron ore or getting the syntax already actually, so or inventory 1 is equal to iron bar, then inventory 1 equals, what do they say, Fancy Quest is trying a new inventory system. As I know, iron bar is always. Let's finish a smelt ore function when a player tries to smelt iron ore. We need to change it into an iron bar, but only if they already have an iron ore in the inventory slot. Well, actually, it's even simpler than that, so we don't need to. Apparently, don't need to check that. Iron ore equals iron. Was it iron bar? And then, yep. Easy peasy. Appending in Python. It's common to create an empty list, then fill it with the values using a loop. We can add values to the end of a list using the append method. So append, Simon. We need to generate a unique user ID for each player in the game. An ID is just a unique number that identifies the user. Let's finish the generate user list function. In the body of the loop, use the incrementing I value as unique IDs and append them to the player IDs. So number of users, so player IDs number of users, so just that. In the body function, using the incrementing I value as unique IDs, append them to the player IDs list, yeah? Oh, sorry. Pop. This is the opposite of append. Pop removes the last element from the list and returns it for use. For example, vegetables.pop. Last vegetable, where's that one? Take from the back. Our player is selling the items in their inventory to the shopkeep. Pop the last element from the inventory list until there is nothing left. Pop the elements into an item variable so that each print returns on line 19. While pop typically removes the last item of the list, it can also be used to remove an item at a specific index. For example, vegetables.pop1 remove cabbage from the list. This can be useful when you need to remove items from other positions in your list. So the assignment is pop the last element from inventory list until there is nothing left. Pop the elements into an item variable so that each print returns on line 19. So item equals counting the items in the list. Remember that we can iterate over all the elements in a list using loop. For example, the following code will print each item in the sports list. Assignment. Our players need a way to see how many copies of a specific item they have within their inventory. Let's finish the get item counts function within the loop. Check if the items are a potion, bread, or short sword. Then add up how many there are of each, incrementing potion count, bread count, and short sword count variables, respectively. Okay. So let's figure out again. So we're going to say item equals items I. I'm going to say if else. So it's going to be if item equals if item equals potion, then potion count plus. I can't remember if you could do that. I think it's plus equals, wasn't it? Plus equals 1. Else elif, yeah. Elif item equals bread, and bread count plus equals 1, and then elif item equals and what is it? Short sword. Then short sword count plus equals 1. Run. Failed. Right, haven't I? Oh, is that the reason why? I spelled something wrong. Potion. I think I just misspelled something. Logic was right. Easy. No index syntax. In my opinion, Python has the most elegant syntax for iterating directly over items in a list without worrying about index numbers. If you don't need the index number, you could use the following syntax. Treat. The variable declared using the in keyword directly accesses the value in the list rather than the index of the value. If we don't need to update the item and we only need to access its value, then it's a more clean way to try out code. So yeah, that's nice. Yeah. When should we use the no index? We want code to write code that is harder to read when we don't need to know the index, just the value. Which method for writing for loops is considered more clean, assuming you don't need the index? For in. Hey, bit slow then. Find an item in the list. Practice the no index or no range syntax. We need to check if a player has a specific item in the inventory. In the contain letters scraps function, use the no index syntax to iterate over each item in items. If you find an item called leather scraps, set the found variable to true. So don't touch the line above this. So for oops, what's it give me autocomplete for? For item in items. If item equals leather scraps with it, leather scraps, then found equals true. Oh, here's the thing again. Leather scraps. Find the increase. So assignment, we keep track of each character's level in a list. When someone levels up, we want to know about it so we can congratulate them. Your assignment is to compare the old character levels and the new character levels lists and to print the index where a character's level increased. The existing code in the loop you've been given loops over all the indexes in old character levels because old character levels and new character levels are the same lengths. You can reuse I to index into both. Fill in the loop with code that prints the indexes where the item is the first list is less than the item in the second is less than the item. We don't want to congratulate someone for staying the same level or somehow leveling down. For example, the lists are then your code printed should be these. 2 and 4. 1, 2. All right, I see 2 and 4. Right. Okay, don't touch above this line. This one don't touch below this one. So, okay, so. If, oops, wrong way. So if old character levels I is less than new character levels I, then print new character levels. So nope, nope, yes, yes, nope, 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 yes, nope. Whoops. I'll do it the other way around because it's a little bit silly that way. If the new character level is greater than the old character levels, $38. Yeah. Fill in the loop with the code that prints the indexes where the indexes. Whoops. There we go. Silly me. So find max infinity. The built-in float function can create a numeric floating point value of negative infinity because every value will be greater than negative infinity. We can use it to help us accomplish our goal of finding the max value. So negative infinity and positive infinity. Because every value will be greater than negative infinity, we can use it to help us accomplish our goal of finding the max value. Assignment. Our players want a way to see their strongest attack from their last combat. Let's add another function to analyze data from our combat log. Complete the find max function that looks at each number in the nums list and returns the maximum value. If no maximum is found, it just returns negative infinity. I've added it for you as a starting value of max so far, for example. Print max infinity stuff. Okay, so I'm going to do for num in nums. For num in nums, and if what you call it? Actually, hold on. We need the thing, don't we? So for get the syntax already. I in oh crud, I forgot the syntax already. Hold on. Why is it just gone out of my head? Or whoops. Let's len oops nums. So if nums is greater than max so far, then max so far equals nums. Run that. Fail. Expecting 5, actually got none. We're just making a silly mistake here, but I'm not sure what it is. Oh, there we go. Just forgot the return. The dummy that I am. Modular operator in Python. Blimey, it's going to be difficult to get through all this tonight, I'll tell you that. What time is it? Not the best in terms of time, but we got to move. The modular operator can be used to find a remainder. For example, 7 modulo 2 would be 1, because 2 can be multiplied evenly into 7 at most 3 times. So it's 2 times 3 is 6, then there's a remainder of 1 getting that from, to get that from 6 to 7. The modular operator's percentage sign is modulo. It's important to recognize modulo is not a percentage though, it's just a symbol we're using. So like 8 modulo 3 is 2. An odd number is just a number that's divided by 2. An odd number is a number that when divided by 2, the remainder is not 0. Assignment. Inside the loop, in the get odd numbers function, use the modular operator to check if each number is odd. If a number is odd, append it to the odd numbers list. The function already returns odd numbers list for you. Number is an integer. So don't touch the line above this, touch this. So if what we're saying, if get numbers, I range so that I modulo 2 is equal to is not equal to 0, then odd numbers dot append and then I. Slicing lists. Python makes it easy to slice and dice lists to work only with the section you care about. One way to do this is to use the simple slicing operator, which is just a colon. With this operator, you can specify where to start and end the slice and how to step through the original list. List slicing returns a new list from the existing list. The syntax is as follows. So my list, start, stop, step. Where to start and end the slice. So at 1 and finish at 5. Start, stop, step. Okay, so start there, and then you step 2, 1, 2, and you stop at 5. So you slice that one and you stop at 5, 1, 2, but it's past that, so it doesn't do it. The above reads, give me a slice of the scores from scores list from index 1 up to but not including 5, skipping every second value. All of the sections are optional. Omitting sections. Whoops. You can also omit various sections start, stop, or step. For example, numbers column 3 means get all items from the start up to, but not including index 3. Numbers 3 colon means get all items from index 3 to the end. Using only the step section, so double colon step gives that. So just like goes, starts at 0, this one, and then skips 2, so it goes 1, 1, 2, 1, 2, 1, 2, all the way along. Negative indices. Negative indices count from the end of the list. For example, numbers -1 gives the last item in the list. Numbers -2 gives the second last item, and so on. So -3 means that from the third last in the list all the way to the end. Third last from this all the way to the end, right? Assignment. Complete the given get champion slices function. It takes a list of champions and should return 3 new lists based on the given champions. First, return the slice of the champions list that starts with the third champion and then goes to the end of the list. So what we're going to do is go slice 1 equals champions. And what does it say? First, return a slice of the champions list that starts with the third champion and goes to the end. So it's going to be 3 colon, and then next return, so slice underscore 2 equals champions. List starts at the beginning of the list and ends with the third champion, so colon 3, and then slice 3 equals champions. Last, return a slice of the champions list that only includes the champions in even numbered indexes, so it's going to be 2 like that, I think. And then so then we're going to return. Takes the challenge to return 3 new lists, so we're going to return slice 1, slice 2, and slice 3. Run. All failed. EP. So input expecting actual. Starts at the beginning of the list and ends with the third champion from the end. Oh, ends with the third champion from the end. Oh. So, -2, like that. Boom. Always read the question properly. Always read the question properly. Thoroughly. List operations, concatenate. Concatenating 2 lists, smushing them together is easy in Python. Just use the plus operator. You just put them together. Assignment. Fantasy Quest allows players to keep lists of their favorite items. Your job is to finish the concatenate favorites function. It takes 3 different lists. The player's favorite weapons, favorite armor, and favorite items. Create a new list that combines the list favorite items, weapons, armor in this order. Return the list containing the combined events. So just do very simple return of favorite weapons plus favorite armor plus favorite items. Run that. Run that. Yay! We're getting through it. They're almost through this one. List operations contains Checking whether a value exists in a list is also really easy in Python. Just use the in keyword. So print banana in fruits. Assignment. Our players are requesting an in-game feature that will allow them to to type in a weapon name to check if it's in the list of top weapons in the realm. Complete the is top weapon function. It should return true if the weapon is in the top weapons list, otherwise it should return false. So don't touch up with this line. So complete this, it should return true if the weapon is in top weapons, otherwise it should return false. So if a weapon in top weapons, then return true. Else return false. Bingo. Right, syntax of Python is really simple. List deletion. Python has a built-in keyword del that deletes items from objects. In the case of this, you can delete specific indexes or entire slices. So this, and then it's like delete the fourth item, delete the second item up to but not including the fourth item, delete all items. In Fantasy Quest, there's a list of strongholds on the map that players can visit to defeat powerful bosses. Let's update the trim strongholds functions. Delete the first stronghold from the list, delete the last two strongholds from the list. So return strongholds. I'll just do a separate thing. So delete strongholds and the first stronghold from the list. So that delete strongholds and then delete the last two from the strongholds from the list. So what's it going to be? Minus one to the end, like that, and then return strongholds. Whoops. Wrong thing, it's not a function. My bad. -2. There we go. Submit. Bushka. Tuples. Tuples or tuples? Tuples or tuples? How would you say it? Are collections of data that are ordered and unchangeable. You can think of a tuple as a list with a fixed size. Tuples are created with round braces, so like this. Okay. While it's typically considered bad practice to store items of different types in a list, it's not a problem in tuples because they have a fixed size. It's easy to keep track of which indexes store which types of data. Tuples are often used to store very small groups like 2 or 3 items of data. For example, you might use a tuple to store a dog's name and age. Note there is a special case for creating single item tuples. You must include a comma so Python knows it's a tuple, not regular parentheses. Because tuples can hold their data. Oh, excuse me. Multiple tuples can be stored within a list. Similar to storing other data in lists, each tuple within the list is separated by a comma. When accessing a list of tuples, the first index selects which tuple you want to access. The second selects a value within that tuple. Okay, this is the first tuple in the list. Yep, 45. Yep. Tuple unpacking. Oh, excuse me. Been a long day. Dog. Fido for dog name, dog age equals dog. Oh, you can easily assign the values of a tuple to variables using unpacking. That's nice, a bit like destructuring in JavaScript. Print dog name, print dog age. When you return multiple values from a function, you're actually returning a tuple. Oh. Fantasy Quest character system needs a list of heroes to be able to run the game properly. Oh, excuse me. Someone wrote some pretty nasty code, and the code in question creates a heroes list where every third index defines a new hero. First their name, then their age, then whether or not they're an elf. Change the heroes list declaration from its current state to a list of tuples. Use the same data for each hero and order in the same way. I can feel my brain going a little bit. Someone wrote pretty nasty code, and the code in question creates a heroes list where every third index defines a new hero. Excuse me. Change the heroes list decoration from its current state to a list of tuples. Use the same data for each hero and order in the same way. Oh, no quote, no quote, no quote. Quote, quote, quote. Easy. First element. Let's add another function to our inventory system. Oh, Chris. Write a function that turns the first element from a list. If the list is empty, then return the string error instead. So if len dot items is less than or equal to 0, then return error. Oops. Else. Oops. Typing's terrible. Else return items 0. A reverse list. Some of our players would like to view their inventories in reverse order. Let's write a function that takes a list as an input and returns a new list except all the items are in reverse order. Okay. Okay. Item in items. So we're going to have a new thing. It's going to be called reversed underscore list equals empty, and then we're going to be so it's going to be I in we're going to do this. We're going to do it in range. Range. That's going to be not to length items. That's going to be, we're going to step back by a -1, and then it's going to be items. Whoops, reversed list dot append. And is going to be items I, and then we're going to return reversed list. Whoops. I've forgotten this already from last time. Whoops. Didn't mean to open that, but... Start, stop, step. What was the reverse was like a -1. Use a negative step value to iterate backwards. Yeah, so I kind of did that. So the length, whoops, like that. It's going to be I, and then items. Oh, they basically did the same thing, right? Okay, I thought they'd done something a little bit more efficient than I did, but no, it's exactly the same. Almost at the end of built of lists. Crikey, it's taken quite a while. Filter messages. You're about to write a bit of more code in a single function that you have before. Do not try to write it all at once. Start with the outermost loop and work your way inwards. Add extra print statements and run your code often to make sure it's doing what you expect. Just make sure to remove the extra print statements before submitting your code. Running your code often to make sure each line is doing as expected is called debugging. All programmers and seasoned professionals break large problems down into small ones that they can debug line by line. Assignment. We need to filter the profanity out of our game's live chat feature. Complete filter messages function. It takes a list of chat messages as input and returns 2 lists. A list. I'm going to start writing it down as a thingy and stuff. So, a list of the same messages, but with all instances of the word dang removed. So, no dangs equals that. And then a list containing a number of dang words that were removed from the message list at that particular index. So index of dangs. Here are some examples. Okay, here's actually create 2 empty lists that you return at the end. One for filled messages, one for counts of the word removed. Oh. For each message in the input list, split the message into a list of words using the split. So for each message list, so for message in messages, split the message into a list of words. So list of words equals message dot split. String method C below for help. Create a new empty list for all the non-bad words for this message. Non-bad words. Create a counter variable. So counter. It's a bad. It's got a collect counter. They want to collect counter, so counter equals 0. For each of the words in the message, if the word is dang, increment the counter. So then, for a word in list of words, we're going to be if the word is dang, increment the counter. If it's not dang, add the word to the non-bad words list you create. So if word equals dang, then counter plus equals 1. Else non-bad words dot append word. Join the list of non-bad words. Join the list of one of those and use strings and join. Append. Append the new clean message to the final list of filter messages. Whoops. So we got messages, input, expecting words removed. Actually, this list object has no join. Non-bad words. Oh, my dummy. There we go. Didn't realize how the join thing works, but it makes sense. Okay, almost at the end. 1, 2, 3, 4, 5 on lists. Evens and odds. You've been asked to write a program that will calculate how many odd and even numbers exist in a list. Challenge: write the get odds and evens function to loop through numbers, list, and check if each number in the list is either odd or even. Increment the num evens counter if even and num odds counter if it's odd. Lastly, return the two values, num odds and num evens in that order. So don't touch above this line. So return num odds and num evens. So for number in numbers, then if let's try and remember this now. So if number modulo 2 equals 0, then it's an even number, so it'll be num evens plus equals 1, else num odds plus equals 1. Oh, that was a crack and a half. Even teams. Fantasy Quest is having a problem where battleground teams are uneven when the match begins. We need a function that will correctly split the two teams evenly. Complete split players into teams function. Use a slice with a step to create two new lists from the players list. Even teams should have the players with even numbered indexes. Odd teams should have players with odd number indexes. Return even team and odd team in that order. Be careful not to assign the wrong values to the variables. Use a slice with a step to create two new lists. Okay, so we're going to do a return. Yeah, we're going to do it sensibly. So even team equals players, and then it's going to be a slice, isn't it? So it's going to be do, and then odd team is equal to players, and it's going to start at 1, and then it's going to step 2 like that. Then we're going to return even team and odd team. Is that right? Yes. Why did I got it first time? Bushka. Alchemy ingredients. Fantasy Quests have added a new alchemy profession. Users would like a way to know how many correctly ordered ingredients they have compared to the required ingredients in their recipes. Finish the check ingredient match function by looping over the recipe list. The function should calculate and return a percentage of correctly ordered ingredients the character has, as well as a list of missing or wrongly ordered ingredients from the recipe. The order of the ingredients matter. They must be in the same index as the recipe to match. The missing ingredients must also be in the same order as they appear in the recipe list. For example, if these were the lists. Oh, my brain. Finish the check ingredient match function by looping over recipe list. The function should calculate and return a percentage of correctly ordered ingredients the character has, as well as a list of missing or wrongly ordered ingredients from the recipe. The ordered ingredients matter. They must return the same index as the recipe to match. Missing ingredients must also be... Okay. For example, if these were the lists, recipe ingredients, percentage, missing ingredients, check ingredients, recipe ingredients. So match, no match, no match, no match. So prints 75 and unicorn hair. Percentage. You can assume that recipe and list and ingredients list will always be the same length in your solution. So, so we're going to have two things. We're going to have Missing ingredients, so I might as well have that. Missing ingredients equals an array, and then what's this going to be? So it's going to be what was it called? Percentage, but percentage. So number of correct ingredients equals 0. What we're going to do is we're going to do for loop. We're going to do for what we're going to check. Penetration flow 9 integer. So we're going to loop over the ingredients and then compare that to the recipe. So the ingredients in ingredients, and we're going to check. So like if ingredient is equal to recipe, although we're not going to quite do that. I in so range 0, and it's going to be len ingredients. So if ingredient ingredients I is equal to recipe I, then number of correct ingredients is 1. Plus equals 1. And we don't record it and stuff. So else missing ingredients, append, then we're going to put ingredients. Oh no, so it's going to be a recipe. Whoops, recipe I. And then what we're going to return. So let's make it for both. So we're going to have a percentage percentage equals 100 divided by hold on, it's going to be length ingredients no sorry it's going to be number correct ingredients. It's going to be that, and it's going to be times by 100, and that's going to give us percentage, comma, and then missing ingredients. Not quite right. Wrong way around. Validate path. Last two on the list ones. Craig gets taken up a lot of the night. Gonna get through some stuff. So validate path. The fantasy quest team is implementing a new type of quest that requires a player to follow a specific path in order to complete the quest. Complete the validate path function. It should compare the expected sequence of waypoints with the actual sequence taken by a character and calculate how accurately the character followed the intended path. Expected path, a list of waypoints that define the correct path of the quest. Character path, a list where the first index is the name of the character and the rest is listed. And the rest of the list consists of waypoints they actually visited. Character path contains the same number of waypoints as expected path. The output function should return two values: character name, a string, and a percentage float. For example, A, B, C, D, D. So validate path at 50% because A matches, no match, no match, match. Okay, so the name is just quite simple. So it's just going to be, name is character path 0. Whoopsie daisy. And then we're going to have number of correct waypoints equals 0. And then we're going to do for in fact, we're going to do character waypoints equals character path, and it's going to be 1 from 1 to the end. Yeah, and then we're going to do for character weight it has to be the I thing, the range again. So I, and it's going to be range not to character waypoints. Then we're going to be if character waypoints I is equal to expected path I, then number correct waypoints plus equals 1. Otherwise nothing. And then we're percentage equals this is just the same calculation again. So character waypoints, so number of correct waypoints divided by the character waypoints length, and then times by 100. Then we're going to return was it character name first, character so name and then percentage. Whoops, forgot to put a length around it. Passed it, run it. Ship it booty, sorry, Mickey, don't get with something like it. Yeah, I suppose I can shorten that. I didn't realize like I can range. I don't have to put the 0. I can just put that. So if expected path I is equal to character path I plus 1. Oh, I didn't have to do split things. So that's one thing they did. Accuracy percentage is the correct count divided by the length of the expected path times by 100. What should I do? Okay. Basically the same. Double the string. The Fantasy Quest team wants to add a new Easter egg potion to Fantasy Quest. It causes characters to have their in-game chat manipulated when they send messages. The potion doubles every character they send. The message they type, hello there. The message that is sent, hello there. Complete the double string function. It takes a string as input and returns doubled version, including spaces. Example input. Okay, double strings. So we're just going to have a new array. So we're going to be string as array. String as array, it's going to be string. String dot splits split split, and then we're going to have a doubled string as array, which is just going to be an empty array. Then we're going to do for character char in a string as array. We're going to do basically double string as array dot append, and then we're going to do char like that, and then return double string as array dot whoops, I forgot the dot join thing goes like that. So it's going to be I've forgotten how to do the string thing. Not that. What was the thing? What was it about? Strings. F strings, was it? Yeah, I'm not doing F strings for else. So F string, and then it's going to be curly brackets that, curly brackets that. Try that. Oh, I see. String into words, and then we're going to do split it again. Is that right? Oh, you can just iterate over the string. Don't have to split it at all. Double string as array. There we go. That was simple. General Kenobi. Hello there, General. Hello there. And General Kenobi. I don't know his voice for it so well, but anyway. Huzzah, we got through that. We're on to dictionaries, and we've got sets, errors, and challenges. Hopefully, these got way less sections, so I'll take it up to maybe 10:30. But we'll see. We'll just see how far it takes to get through. There's not as many in these ones, so hopefully get through it a little bit faster. Although I'm not familiar at all with dictionaries, as long as they're not that different from objects. Dictionaries in Python are used to store data values and key value pairs. Dictionaries are a great way to store groups of information, so we use curly braces, add key value pairs. Here the car variable is assigned to a dictionary containing keys brand, model, and year. The keys corresponding values are Tesla, 3, and 2019. Assignment: complete the get character record function. It takes a character's name, server level, and rank as individual inputs and returns a dictionary with the following string keys: name, server level, rank. Create and return a dictionary with the keys with the keys above. Assign each of the 4 inputs to the matching name. Blah, 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 blah. Next, we can have 2 characters named Next, we can't have two characters named Blood Warrior 123 on the same server. For the fifth key ID, create a unique value as follows: concatenate the name and the server inputs with a hashtag in the middle, or £. For example, Blood Warrior 123, blah blah blah. Okay, so let's do that. So we're just going to do this really simple, just like that. They have to be in keys like that, yeah. So like that, it's going to be name, comment, that's going to be, oops, server, that's going to be level, and it's going to be rank, and then the last part, what was it, Blood Warrior. So I like doing F strings, so I'll do like that, and then what was it, name, and then pound server. So past Bushka. Easy McSqueezy, we're getting through this one fast. Duplicate keys. Because dictionaries rely on unique keys, you can't have two of the same key in the same dictionary. If you tried to use the same key twice, the first value would simply be overwritten. Another developer on our team has introduced a bug specifying duplicate keys in the dictionary. Fix the bug. The get character record function takes a character's name, server level, rank. It should return a dictionary that follows name, server level, rank, ID. Where the ID is the name, so it can concatenate with a £. So I did that. That's the problem, and that's the problem. Accessing dictionary values. Dictionary elements must be accessible somehow in code, otherwise they wouldn't be very useful. A value is retrieved from a dictionary by specifying its corresponding key in square brackets. Square brackets look similar to indexing in a list. You have the key. Which kind of brackets you use to access it? Square. Setting dictionary values. You don't need to create a dictionary with values already inside it. It's common to create a blank dictionary, then populate it later using dynamic values. The syntax is the same as getting data out of a key. Just use the assignment operate equals to give the key a value. So planet Earth is true, planet Pluto is false. Sad for Pluto. Assignment, use the example below to answer the question. Names, Jack Bronson, Jill McCarthy, and John Denver. Names dictionary font. Name in names. Split returns a list of strings where each string is a single word from the original. So name list. Here we update the dictionary. So names dict, name list equals name list 1. Okay. Which is the correct syntax to create a new key value pair in an existing dictionary? That way. What happens if you assign a new value to existing key? The value updates, the key value. That. What happens if you try to delete a keyword that doesn't exist in the dictionary? Alright, deleting dictionary values. You can delete existing keys using the del keyword. Deleting keys that don't exist. Notice that if you try to delete a key that doesn't exist, you'll get an error. Error. Awesome. How many we got? So, okay, got a few. We can get through it. We're almost there. Oh, I'm just checking on something. Yep, everything's looking good. Okay, anyway, so checking for existence. If you're unsure whether a key exists in a dictionary, use the in keyword. print forward in cars. So we need to be able to report to our players how many enemies are in their immediate vicinity, but they want the count of each enemy by its kind. Fix the count enemies function. If you run the code, it will result in a key error. It takes a list of enemy names as input. It should return a dictionary where the keys are all enemy names from the list, and the values are the counts of how many times each enemy appeared in the list. So we fix the count enemies function. If you run the code, it was a key error. It takes a list of enemy names as input. It should return a dictionary where the keys are all the enemy names from the list, and the values are the counts of how many times each enemy appeared in the list. So inject enemy name, names, plus 1. So if enemy name in enemies dict, then I'll say that wrong. Else you do like not in a camera, not in, and then not in. Yeah, I remember the not syntax. I haven't used that for ages. I remember off the bat. I didn't need to cheat on out. Iterating over a dictionary in Python. We can iterate over a dictionary's keys using the same no index syntax we use to iterate over the values in the list. With access to the dictionary's keys, we also have access to their corresponding values. So fruit sizes. Fruit sizes. So then we've got size, fruit size and name. Gives you the name, so it's the key. Name, key, and size. Note we could have easily set the name variable to key or simply k. Assignment: we need to display on our play screens what the most common enemy in a given area of the game map is. Complete get most common enemy function by iterating over all enemies in the dictionary and returning only the name of the enemy with the highest count. If there are no enemies, return none. If there are multiple enemies with the same highest count, return the first one found. Enemy sticks to the dictionary of name count, example like that. Tip: negative infinity. When you're trying to find a max value, it helps to keep track of the max so far in a variable, so that and to start that variable at the lowest possible number, negative infinity. So I'll copy that. Obviously saying it's useful, so max so far. You'll also want to keep track of the enemy name associated with the maximum count. I would set the default flat to be variable none, so max enemy name none so far. And then what we're going to do is we're going to do for enemy in enemies dict. So then I guess if enemy is dict enemy's dict enemy is greater than max so far, then max so far equals that, equals enemy dict enemy, and then max enemy name equals enemy. And then return, we're going to return so max enemy name. Try that. Passed it straight away. Boom. I used to like the non and thingy and stuff. Very nice. Ordered and unordered. As of Python version 3.7, dictionaries are ordered. In Python 3.6 and earlier, dictionaries are unordered. Because dictionaries are ordered, the items have a defined order, and that order will not change. Unordered means that the items do not have a defined order, so you couldn't refer to them by using an index. The takeaway is that if you're on Python 3.7 or later, you'll be able to iterate over dictionaries in the same order every time. Python dictionaries ordered. Oh, before. Whoops, I said over. Never mind. Quest status. So Fantasy Quest needs a way to check the status of individual characters' quest status. The game stores each character's progress in a nested data structure, and your job is to fetch the status of a particular quest. Here's the structure of a progress dictionary. Assignment: complete the get quest status function. It accepts a progress dictionary and returns the character's status in the bridge run quest. Chain the keys to access the nested data. Okay, so we're going to have quest status equals none. And we're going to do for quests in progress, and then it's going to be entity character, and then we're going to be in that if quests, whoops, so it's going to be like that, and it's going to be quests if quest is equal to the bridge just go run, then quest status equals I don't even need to do any loops. I can just do return this. That's going to be Woo! Okay, got 2 more in dictionaries, and then we're on to sets. I think time-wise, we're doing not too bad. Recently added Fantasy Quest Battlegrounds are having issues with their in-game score due to how the data is being stored. The first half score and the second half score are stored in separate dictionaries, making it difficult for them to pass the overall score. You've been asked to write a function that merges the 2 dictionaries and another function that calculates the total score. Complete the merge and total score functions. Merge. Complete the merge function. Accepts 2 score dictionaries as input and returns a single merge dictionary that contains all the elements and values from the input directories. If a key exists in both dictionaries, the value from the second dictionary should override the value from the first dictionary. Here is an example of how the merge function should execute when implemented correctly. So, 2 towers will return the king, Frodo, 1 ring, Aragorn, Narsil. So Aragorn, Andúril, Gandalf, Glamdring. Oh, so they don't crash. Oh wait, no, they do. They clash on Aragorn for the thing. Okay. Oh, so we'll do that first. So we'll do the merge. So we want the thingy to roll. So we're going to have merged underscore dict equals object, and then we're going to do for name in we have to do the range thing again. The name in dict 1. We're going to do merged dict name merged dict name equals dict 1 name, and then we're going to do for name in dict 2, and we're going to do merged dict name equals dict to name. I got really confused then thinking about the logic for that one. And then we're going to return merged dict. Boom, that was easy. Hey, last one, vendor. So, vendor. Fantasy Quest players want a way to track what items they purchase from the vendor, how much it costs, and what they still need to purchase from the tracked items list. Complete the calculate total function. Inputs items purchased, a list of the names of items purchased. This is a list of strings. Pinned list, a list of the names of items, and a list of the names of items the player has pinned and wanted to purchase. This is also a list of strings. Outputs the function should return 3 values in this order: unpurchased items, a list of all the item names in pin list that weren't found in items purchased in the same order they originally appeared in the pin list. Receipt, a dictionary containing all the items the player has purchased, even stuff not on their pin list. The keys are the items names and the values are the respective prices from the items price dictionary. Total, the total cost of all the items that were purchased. Return each value separately, not in a singulars, for example. Return each value separately, yeah? Do you have to put this line? Okay, so we're going to do return. That's going to be, copy it because I'm lazy. Unpurchased items. Receipt. And total. So unpurchased items is going to be a variable, so going to be unpurchased items equals that. Receipt is going to be a dictionary, and total is going to be a number. Okay, so we're going to loop through items purchased and pin list item prices. So items purchased, listen, all the so for a list of the names I purchased. This is a list of the names of the items players pinned and wanted to purchase. This is also a list of all the item names in the pin. So like we're going to loop through all in the same order they originally appeared in the pin list. Receipt, a dictionary containing all the items players purchased, even stuff not on their pinned list. Even stuff not on their pinned list. Right, okay, so we're going to do 2 different loops. So we're going to do on purchase items. So we're going to loop through the on purchase in the pin list that were not found in the items purchased. So we're going to do that first. So in so pinned in pinned list. Then we're going to do so if pinned not in items purchased. Then we're going to do unpurchased items dot append, and then the pinned one. So run that. So I got the first bit right. Okay, then we're going to do another loop. So for receipts, so for we're going to loop over the items purchased, item in items purchased. Dictionary contain all the items a player's purchased even still on the list. The keys are the item names and the values of the respective price from the items prices. So for purchased, I suppose we need to check it, but we'll do that. So receipt dot item equals item prices item like that, and then we're going to do one final one where total cost of all items that were purchased. So for item in receipt, we're going to do for item receipt, we're going to do total plus equals receipt item. Run that. Passed. Run it all. Works. Nice and simple. I think it was pretty succinct. And boom, we are done with dictionaries. So sets, errors, challenges. That's what's left. Sets is not very long, so what I think I'll do is I'll do sets and I'll see what errors looks like. If errors is not super long, then we'll give that a go as well. But if it's long, we'll just have to finish off tomorrow, do the quiz, do the challenges, all that tomorrow, and then move on to the second set. Speaking of sets, sets are like lists, but they are unordered and they guarantee uniqueness. Only one of each value can be set. So type fruits class set. Add values. No error will be raised if you add an item already in the set. Like lists, but they are unordered and they guarantee uniqueness. Only one of each value can be in a set. Add values. Empty sets. Because the empty bracket syntax creates an empty dictionary, you can create an empty set. You need to use the set function. Iterate over values in a set order is not guaranteed. So for fruit, in fruits, print fruit, it prints banana, grape, and apple. That's kind of annoying. Complete the remove duplicates function. It should take a list of spells that a player has learned and return a new list where there is at most one of each. You can accomplish this in at least two ways. Iteration. Create a set to track spells that have been seen. Create a list to store the unique spells. Iterate over the list. If the spell is not in the set, add it to the set and the list, return the list. Or set conversion. Convert the list to a set. Convert the set back to a list and return it. I want to try that one, so it makes no sense to learn a spell twice. I'm try this. So convert set list to a set. Set spells set equals set and spells, and then back to a list. I'm guessing you could just do so. Spells list equals list of spells set, and then return spells list. Is that the way? There's the way. Very easy. Sets quiz. We're already getting to quiz. I ain't much to do around sets. It's very basic. Sets quiz. That's what we do as well. Sets are like so. Yeah. How do I remove an item from a set? That's a good point. Does this? Oh, it does say remove. Set remove item. What is the type of myval in the following? That's a dictionary. I get tripped up by that. Which could be a good use of a set? To store ID user pairs, to store all the possible spells in the game, to store all the enemies in game by difficulty. That one. Maybe. Boot.dev having a little think. Yay! There we go. That's sometimes a little bit slow responding. I wonder if it's busy. Goes down a little bit. Duplicates. Players are complaining that they aren't able to see their collections easily. Currently, every collectible item is displayed, even the duplicates. Players only want to see each artifact once, even if they have collected more than one of them. Complete the remove duplicates function, accept the list of strings and removes any duplicate values you should utilize and return a set, not a list. Can't we just do return set and then list like that? You can write the body of the function in single line of code. Yeah, well, that was basically the thing, wasn't it? That's nice. Vowels. You have been hired by a blogging company and they are asking you to analyze one of their recent posts to determine the number of vowels present in their paragraphs. Complete the count vowels function. It should take a string and return a count of the number of vowels within the given string and a set of its unique vowels. For this challenge, we are only interested in the 5 vowels A, E, I, O, U and their capitalized versions. In addition, treat uppercase and lowercase vowels as separate. For example, A and A are not the same. Okay, count vowels. So complete should take a string and return a count of the number of vowels within the given string and a set of its unique vowels. Return a string. It should take a string and return a count. So count of the number of vowels within the string. Should we count? All right. Okay. So number of vowels equals 0, and then vowels within the same string and a set of its unique vowels. So we return number unique vowels and unique, let's call it vowels. So unique vowels equals text.split. It's going to split to a thing, and then it's going to be a basic array like that. So a list, and then we're going to do set on that. It'll just give us the things. So words equals text split like that, and then for a word in words. We're going to do if and then actually we're going to split again, aren't we? So characters equals word dot split. Oops, word dot split. And we're going to do basically for loop again, so we're going to do for character in characters if character to make it things like, we'll call it vowels equals just like this. It's going to be A, E, I, O, oops, U. And the if character in vowels, then number of vowels plus equals 1. Unique set vowels. So E, I, O, U. And then vowel, unique vowels. Do you add. That was it. That's what I was looking for. Not quite. Unique vowels. Character in vowels. Array. I'm going to check array. Like lists. So list in Python. In. Let's go try it. So print character run. Now, what's the thing? Python split word into letters. Bingo. I'm getting my things mixed up. Whooshka. And we're on the last one of set, so we're doing a good time. Can I start my timer? We're going to finish sets definitely, and then I'll have a look, see if errors are it's quick enough to do. Could probably do that. Right, let's have a look. So we're on sets and we're on differences, the last one. So the fantasy team merged some of the servers together, but the merge didn't go perfectly. The resulting lists have duplicates and missing IDs. We need to clean up the duplicates and find the missing IDs. Assignment: complete the find missing IDs function. It accepts two lists as input, returns a new list of all the IDs present in the first list but not the second. Make sure to remove any duplicates. So complete find missing IDs function accepts two lists as input and returns first ID, second IDs. Returns a new list of all the IDs present in the first but not in the second. Make sure to remove any duplicates. Two lists. All the IDs present. Set from another. So first and second IDs set second IDs, and then we're going to do dupes calls first IDs take second IDs, and then we're going to do return removed dupes as a list. Easy McPeasy. Nice. Chapter 12. It's nearly thinking stuff. Can we whiz through this? How difficult is this going to be? We do it. We finish it, because then it means tomorrow we move on to challenges and a quiz, and then we go on to the next module. Like we smash this out tonight. Let's do this. Let's do this. We're here. We smash it out. Errors and exceptions in Python. You've probably encountered some errors in your code from time to time if you've gotten this far in the course. In Python, there are two main kinds of distinguishable errors: syntax errors and exceptions. Syntax errors, you probably know what these are by now. Syntax is just the Python interpreter telling you that your code isn't adhering to proper Python syntax. It's not valid code, so it will error. If I tried to run that sentence, if it was valid code, I get the syntax error, syntax valid, invalid syntax. Exceptions, even if your code has the right syntax, however, it may still cause an error when an attempt is made to execute it. Errors detected during execution are called exceptions and can be handled gracefully by your code. You can even raise your own exceptions when bad things happen in your code. Python uses try except pattern for handling errors. The try block is executed until an exception is raised or it completes, whichever happens first. In this case, an exception is raised because division by 0 is impossible. The except block is only executed if an exception is raised in the try block. If we want to access the data from the exception, we can use the following syntax. Exception as print E, prints division by 0. Wrapped potential errors in try/except blocks allow the program to handle the exception gracefully without crashing. Assignment: one of the calls get player record is throwing a player ID find exception. Change the code in the main function safely. Make all our 4 calls within one try block exception. If an exception is raised, print the exception instead. Okay, so Yeah, what's wrong with it? Whoops, I wasn't meant to edit below that line. Uh, Whoopsie daisy. That was my bad. Big dummy I am. Alright. 12 things. Can we do it? Yeah, come on. Let's do it. So try block is executed until an exception is raised or it completes, which I have first. In this case, a divide by zero. Okay. If no exceptions are raised in the try block, the except block will execute. The except block executes. Will execute. If the exception is raised outside of the try block, program crashes and prints the exception. Oh, crikey, no, we've got a video. Gotta get my things on then. Let's get this on. Raising your own exceptions. Okay. Okay. Oops. Errors are not something to be scared of. Every program that runs in production is expected to manage errors on a consistent basis. Our job as developers is to handle errors gracefully in a way that aligns with our user expectations.
Let's talk about the difference between bugs and errors in code. And I think this is an important topic because a lot of newer developers I don't think quite appreciate the difference between bugs and errors, because from the user's perspective, like in your pre-developer life, I think these two words sometimes get maybe conflated or used synonymously, but there's actually a really big difference. So let's give some examples. An example of a bug would be something like the program crashing. Let's say like your application crashes on maybe some specific user input. So say you have like an online game. If someone types the word crash into the chat, the game just crashes. It's all over, right? That would be a bug. It's basically unexpected. This is the important part. Unexpected. It's unexpected behavior is what a bug is. Okay, an error, on the other hand, isn't necessarily a bad thing. It's just something you plan for. So, for example, an error might be, again, using the example of an online game, it'd be like internet connection lost, right? So you're writing your code. You have to plan for the fact that it's possible that the person running your code, the person playing your game, essentially loses their internet connection. That's not a bug in your code. There's nothing you can really do about that as a software developer. But it's something you need to plan for, and it's something you need to handle. So errors are expected, and we handle them, right? We handle errors. Okay, so bugs and errors, the big difference is bugs are always bad. Like if you have bugs in your code, you need to fix your code, right? And what that means is, so say a user encounters a bug, they say, hey, my program's crashing, or hey, this sword is supposed to do 250 damage, but it's actually only doing 100 damage. Like the only solution to a bug is to go fix the code. So you go fix the code, right? When an error occurs, hopefully your code already is built in such a way that it handles it. Now, it's worth pointing out, if errors are happening and they're not being handled properly, then that is a bug, right? But the bug isn't the fact that the error is happening. The bug is the fact that you're not handling the error properly, right? So what is an error? Like from a more literal perspective, what is an error in code? Well, if you're in Python, the way errors happen typically is that the developer actually raises them intentionally. So there's kind of this keyword, right? Raise. So you can raise an exception. And in Python, an exception is an error. That's just the word used. In JavaScript, you would throw an error. And in Go, you would return an error value. Right. So these are things that we actually plan for in our code, right? We're raising exceptions, we're throwing errors, we're returning errors, and then when those errors happen, we are actually writing code that does something. So for example, say internet connection was lost, the way we would handle that is we might do some retries, right? So we're sending a network request, it fails because there's no internet connection. Maybe we wait 5 seconds and we try again, right? And then we wait 10 seconds and then we try again. That would be one way to handle an error. Another way we can handle an error, this is a pretty common way, is just to alert the user. So for example, maybe we require 8-character long passwords. The user enters 6 characters, we throw an error, and the way we handle the error is by telling the user, hey, you need to put in another 2 characters into your password. So that's errors. And really, if you get nothing else from this video, I just want you to understand bugs are always bad. The definition of a bug is something unexpected happening in your code. And the only way to fix it is to go back and work on your code. Find where your code is doing something where you didn't expect it to be doing that thing, right? You expected a sword to be doing 200 damage. It's only doing 100 damage. You have to go find in your code why that's the case. Whereas with errors, if errors are happening, as long as you're handling them gracefully, that's all you need to do. So hope this helps.
Yep. When something in our own code happens that isn't, how far are we through? Yeah, okay, near it. When something in our code happens that isn't the happy path, we should raise our own exceptions. For example, if someone passes some bad inputs to a function we write, we should not be afraid to raise an exception to let them know they did something wrong. An error or exception is raised when something bad happens, but as long as our code handles it as users expect it to, it's not a bug. A bug is when code behaves in ways our users don't expect it to. For example, if a player tries to forge a sword out of a metal bar, we raise the exception if the game can't support crafting a sword from that metal type. However, that's expected behavior of the game, so it's not a bug. If a player can forge a sword out of gold, that may be considered a bug because that's against the rules of the game. Don't catch your own exceptions. As a rule of thumb, you do not want to catch exceptions you raise in the same function block. For example, try, put an exception like that. Instead, the caller should handle any potential error by wrapping the function call with a try except block. Assignment. If a player ID that doesn't exist is passed into the get player record function, we need to raise but not handle our own error to alert the to alert the core of a function that the player they are looking for doesn't exist. The exception should be should say player ID not found. So no, the test will call player record function will handle exception you raise. So is it going to be raise exception, and it's like that, like that. So we passed that, and it passed it all. Raising exceptions review. Software applications aren't perfect, and the user input and network connectivity are far from predictable. Despite intensive debugging, unit test applications will still have failure cases. Loss of network connectivity, missing database rows, out of memory issues, and unexpected user inputs can all prevent an application from performing normally. It's your job to catch and handle any and all exceptions gracefully so that your app keeps working. When you're able to detect that something is amiss, you should be raising the errors yourself. In addition to the default exceptions that Python interpreter will raise. Which keyword triggers the exception Python raise? Good code doesn't need to handle errors. It should be error-free. False. Yeah, I think we're getting to the end of this fairly quickish. Different types of exceptions. You haven't covered classes and objects yet, but which is what an exception really is at its core. I'll do we'll go more into that in a course in object-oriented programming. For now, what's important to understand is that there's different types of exceptions. You can handle them differently depending on the situation. Some exceptions are more specific, like zero division error or index error, and some are more general, like the base exception. Syntax try, zero division error, okay, index error, exception, index error, why specific exceptions come first. When handling exceptions, it's important to catch the more specific ones first, because Python stops checking once it finds a matching exception handler. If you catch a more general exception first, any specific errors will never get handled individually. In this case, the general exception will catch the error before the index error can be reached, and the message index error will never be printed. Always handle more specific exception first. Alias accepts the messages. As seen in an example, you can also access the error using as like this. So yeah. The default behavior of print is that it will print the string representation wherever the object is passed into it. In this case, it will print the error message. Take a look at the get player record function. It raises an exception for negative player IDs. Complete the handle player thing should return the result of get player record, but if an index error is raised, it will instead return error. So try, and it's like get player record and then player ID. So return and then accept and what was it, index error. So index error and print this is too high. Accept and there's an exception Z, and then print E. Bingo. You notice that there are many types of if the code example will happen, the program will crash within a quite exception. It'll print 0. What differentiates exceptions are their types, not their string descriptions. This is important to note when handling errors from imported modules. If you're interested, it won't print 0. Oh no, it will. Program crashing and quite exception. It's the wrong one. Yeah, it's not a general exception. Have you noticed there are many types of in the code example, what will happen? Raise exception, print other. In the code example, what will happen? Print other. Oh, almost done, Bubby-o. And then tomorrow we'll be wrapping it up. Purchasing. There's a bug in the current vendor system that is letting players buy items from the shop even when they don't have enough gold. So complete the purchase item function. If the character doesn't have enough gold, raise exception with the text not enough gold. Don't handle the exception. So if gold available is less than the price, then raise exception on that. Now I have gold. Otherwise, return the amount of money the customer has left over after completing the purchase. Else return price minus gold available. Return. Whoops, don't need to return that. Bingo. Purchasing. Now we need to use our purchase item function to process an entire list of character purchases. Don't need my things anymore. Complete the process transactions function. Complete the process transaction function. It takes a list of purchase orders. Each order is a dictionary. Look through the main function to see the shape of this data. Oh, blimey. Right below this line. Takes a list of purchase orders. Each order is a dictionary. Look through the main function. First, create an empty list of leftovers. So, leftovers equals list. Then loop over the list of purchase orders. So, for purchase orders. For each order, try to process the order with the purchase item function. If exception is raised, prints the exception. So try purchase item. Purchase item takes price and gold available. So purchase item. Then purchase. Remaining gold equals purchase item how do you spread something in? So arguments. Um, if there's not an error, then the purchase successful. Append the remaining money to the leftovers list. So remaining gold. Remaining gold. So leftovers dot append remaining gold. Append the remaining money to leftovers list. If there is an error, don't add anything to leftovers. Be sure to loop over the entire list of purchase orders. Finally, after the loop is ended, return leftovers. Booshka. Easy. Wow, we were okay. We are on to challenges. And this will do it for tonight. Blimey. Yeah, so tomorrow we'll be finishing off this module and moving on to Learn Linux, which has got significantly less modules in it, although maybe it might be more to watch or more, I'm not sure. The length of things are going to vary in these modules. Wait for it, you might finished. But yeah, so we're doing all right. So next week we're going to be streaming again on Wednesdays and Thursdays, as always. I think next week I might even start streaming on Twitch. So if you prefer seeing us on Twitch is your platform, go see us over there. I'm going to try and get set up for next week to do that. So that's it for tonight. Tomorrow we'll finish off this module, and next week we will just keep continuing. We'll learn the Linux and all that, and just keep going. Hopefully there'll be some YouTube videos out next week as well. Thanks very much for coming. Have a good night, and